Hi and welcome to Racecraft once again. As you can see, I've got another Sigma. This is a really mint car. It's only done 41,000 Ks. It's almost a shame to put a V8 in it, but it's going to get the V8 anyway. So what I'm going to have to build for this car is a Diff. Now, I've shown you how to build a Diff in one of my previous videos, but this time I'm going to do it in a little bit more detail so you see exactly what goes into pulling the axle tubes out and all that sort of thing. So I'll get a Diff set up and we'll show you how it's done. This is a Borg Warner Diff out of a Falcon, out of a V8 Falcon. This particular one's out of a Ute. You probably tell by these spring pads on it. The ones out of sedans have got a whole bunch of brackets on there. But anyway, that doesn't matter because we're going to cut the axle tubes off. Now, the reason that you cut the axle tubes off, one is to make it easier to manage, but the other is that we don't care about the axle tubes because eventually we're going to press them out of the Diff. So the first thing you need to do is to take the crown wheel and the hemisphere and everything out so that you've got good access in there. You can leave the pinion in, so when you go to reassemble it, you can just put it back together. But remember, when you do pull it apart, the shims that are in there and the bearing cups that go onto the side of the hemisphere, make sure you label which side came out of which side. That is important to do. So when you go to put it back together again, the bearings match the bearings that are on the hemisphere and you've got the right spaces in the sides. So I'll cut that now with my trusty little bandsaw here, and then we'll go on to these puddle welds here which we need to drill out so we can actually get the tubes out. I've cut the Diff, now I've set it up in the milling machine. Now I realise that if you're doing this at home, you're not going to have a milling machine to do it in. The reason that I've done it here is because I can. It's all nice and steady and I can go through with a tungsten carbide bit and drill it. But you can drill this at home. Now if you have a close look here, okay, you should be able to see that that drill was actually drilling into that without too much trouble. That's fine, it'll drill through the weld, no trouble at all. Where you will have problems is when you get to the interface between the weld and the cast iron, because the weld hardens the cast iron. This is the mongrel part of the job. So be prepared for the fact that you're going to resharpen a whole lot of drill bits as you get bigger and bigger in diameter. So we're going to go ahead now and drill these welds out, and then I'll go into how you actually press the tubes out. Okay, so I've drilled these welds out. There's 3 of them in there. You've got to drill a fairly large hole to make sure that you get all of the weld out. Otherwise, when you go to press this axle tube out, you're going to crack the housing around the edge here. So be prepared to drill a fairly substantial hole. This is 22mm or about 7/8 of an inch. That's about the size hole that you need to drill. You could probably hear that squeal, squeal, squeal noise as this cutter's going around. That's the cutter cutting through that really hard boundary layer that's between the weld and the cast iron. It is very, very hard. If you are trying to drill this with a conventional drill, you're probably better off going to the hardware and buying a tip drill, a tungsten carbide drill. You probably will have to sharpen it a couple of times to go through. Can be done, but I'm not going to lie to you, this is difficult to do. I've drilled out all the welds. There's 6 of them in all, so I've drilled them all out. So the next step will be to press these axle tubes out of the housing itself. Now, in order to press them out, you need the support this area of the cast iron. If you just put it between two beams and try and press it out, it'll probably crack next to the hole. So I just made up this big ring here, which is a neat fit on the end there. So that can then go into the press. Then weld a bung into the end of the axle tube. So you bung off the tube and then get a substantial steel bar and put it through the diff housing. So because the hemisphere is out, so this will just go straight through. Put it in the press and then press on that end, and that'll push that tube out for you. They're not easy to get out, they're quite tight. Might even have to run a bit of oxy around the edge there just to help loosen it, but they will press out. We're ready now to press our axle tubes out. What I've done is I've cut that bit of excess tube that you probably saw when I had this in the milling machine right down here close to the cast iron. Now the reason for that is that when I put my plug in there and weld it in, I'm going to push it right down, right to the edge of the hole there, and then by welding it I'm going to pour quite a lot of heat into this area here. So I'm going to go around a couple of times with the welder and make sure I get a whole lot of weld in there. Two things are going to happen. One, the heat will expand and hopefully break the bond that the axle tube has with the cast iron, but when the weld cools it will contract and hopefully pull our axle tube in a little bit and make them easier to pull out. In the past I've had to get the oxy out on here, but I've left the axle tube quite long, so this is a bit of an experiment at the same time. We'll see how this works. So I'm going to put that little cap in there now, tap it down, just get it level with those holes. There we go, that's just level with the hole. So I'll fire up the welder now, get those welded in, then we'll try and press it out. Alrighty, you can see that we've got it nice and hot. The old oil there is burning off, and we've got a nice big weld in there. The more weld you put in there, the better chance you have of it shrinking down as the weld cools. Anyway, we'll let that cool down. We'll stick it in the press and see how she presses out. So I've got the diff set up now in the press here. I've got an old axle here to press down. I've got my support ring there to support the cast iron part, and we'll see how she presses out. So you've got to connect the air up now, so it'll get a little bit noisy. That was it. She's out. So as you can see, I'm doing 3 of these at present. One of them's a Holden diff. They're all Borg Warners, or actually BTRs, but there's some interesting differences between these two. Definitely the Ford one is a stronger housing, which is quite interesting. I'd never noticed this before when I've mucked around with these diffs. If you have a look at the webbing in this area here, you can see that's scalloped right out. On the Ford diff, that's filled right in. So there's quite a bit of difference there between the web on that one and the web on this one. The other difference is also the web that runs across the top of the diff here. You can see that's only about 10 millimeters or so high. This one's more like about 15. Definitely a stronger housing. The other thing is that Ford puts 3 welds into their diffs. Holden only uses 2. So if you've got to drill these welds out, which are really tough to drill out, you'd rather be drilling only 2 holes in each side of your Holden than 3 holes in your Ford. But the Ford's definitely a stronger housing, even though they're made by the same manufacturer. That was actually quite interesting. Anyway, that's it for this particular video. I haven't had a chance yet to pull a Sigma diff out of my donor car. As soon as I get that out, I'll show you how to cut the center out of that and save the axle tubes, and then put them into your big diff, how to line it up and all that sort of thing. So, thanks for viewing.